Hey guys, in this video we're going to be looking at the practice problems from 8.2. And 8.2 was really focused on identifying those perfect squares and then simplifying radicals. So let's look into this. For number 1, it says simplify the square root of 16. 16 is a perfect square. I know 4 times 4 is 16, so square root of 16 just simplifies to the whole number 4. Number 2 says 4 times the square root of 27. So I have a coefficient of 4, and I've got, underneath my radical, I've got the radicand of 27. So while 27 is not a perfect square, I know that the perfect squares below 27 are 1, 4, 9, 16, and 25. And I know that 9 is a factor of 27. That means that something times 9 will equal 27. And looking at my multiplication factors, I know 9 times 3 will yield 27. So I'm going to continue bringing that down. I got 4 times the square root of 9. So I'm just breaking that whole radical into 2 separate radicals, because that's just the properties of multiplication. It doesn't matter how you write them. They still mean the same thing. And now I can simplify that square root of 9 to become the value of 3. So I've got 4 multiplied by 3 multiplied by the square root of 3. And the last step I have to do is simplify my coefficient here. 4 times 3 is 12. So my simplified radical is 12 square root of 3. Meaning that 4 square root of 27 is the same thing as 12 square root of 3. So they're the same radical, it's just 12 square root of 3 is our simplified version. Then we get to the square root of 20. Square root of 20, right now we don't have a coefficient on this, but we need to see if 20 has any perfect square factors. So I've got 1, 4, 9, 16, and then 25 is too big. 16 is not a factor of 20, 9 is not a factor of 20, but 4 is. I know 4 times 5 is going to yield 20. So let's go ahead and write that out. I got 4 times 5. That's going to give me the square root of 4 multiplied by the square root of 5. And we know that the square root of 4 is 2. And I'm going to bring down that square root of 5. So the square root of 20 is going to simplify to 2 times the square root of 5. That gets us to problem 4, which is the square root of 36. Now 36 is a perfect square, so this simplifies just to the value of 6. Now we've got 22. So I'm looking at my perfect square factor, the square root of 22. I'm looking at my perfect squares that are less than 22. So that's 1, 4, 9, 16. Nothing multiplied by 16 will get me 22. Nothing multiplied by 9 will get me 22. And nothing multiplied by 4 will get me to 22. So therefore, the simplified version of the square root of 22 is just the square root of 22. That leads us to 2 square root of 80. Now, I'm going to show you guys how to do this 2 different ways. We could go through the way of, all right, let's find our largest perfect squares here. So I've got 1, 4, 9, 16, 25, 36, 49, and then 64. And then after 64, that gets us to 81. So that's everything bigger than that would not be a factor anyways. And if you know some of your factors of, or if you know some of your multiplications, you may know that 16 times 5 is going to get us to 80. But that might not be the first thing that you see, and that's okay too. So I'm going to show you how it would break down the fastest way, and then I'm going to show you how you could break it down if that's not a reasonable choice for you. Like if you don't know that 16 times 5 equals 80, that's okay too, because we can still get to the same simplification with a couple more steps. So I've got 2 square root of 80. I know I can break it into 16 and 5 just because I told you guys that. And this is a multiplication that I know about. And I know that the square root of 16 is 4. So this is 2 times 4 times the square root of 5, which is going to simplify to 8 square roots of 5. But we can do the same thing with smaller square root factors, or with smaller factors. So if I'm looking at 2 times the square root of 80, I know that 4 is a factor of 80 because 4 goes into 80 20 times. Well, I know 4 goes into 8 2 times. Add a 0 to it. That's 4 times 20. So we can break it to that, which is fine. I've got 2 times the square root of 4 times 20. That'll give us 2 times the square root of 4 times the square root of 20, which is 2 times the square root of 20, which is 4 square root of 20. But we're not done yet, because 20 can also break down. We saw how 20 broke down, and if I'm looking here at problem 2, or problem 3, repeated, sorry about that. But if I'm looking at the square root of 20, I know that breaks to 2 square root of 5, but we can do that again. 20 is going to break down to 4 times 5. So I got the square root of 4 times 5. I still have that coefficient of 4. So let's continue simplifying that there. I got 4 times the square root of 4 times the square root of 5. And the square root of 4 is 2. So that leaves me with 4 times 2 times the square root of 5. And that also simplifies to 8 square roots of 5. So we had a lot more steps, but we got to the same value. And that's okay if that's what works best for you. You have to do what works best for you in these cases. What's funny, we're gonna do a similar idea here. We got the square root of 8. I know that the multiples of 8, or excuse me, the factors of 8 are 4 and 2. So I'm gonna go ahead and use that 4 times 2. And the square root of 4 is gonna simplify to 2 times the square root of 2. And that's our simplified version. Leading us to our last problem here. It says simplify the square root of 18. I know some perfect squares that are lower than 18 are 1, 4, 9, 16. And 9 is a perfect square factor of 18. So I can rewrite the square root of 18 as 9 times 2. So that's going to give us the square root of 9 times the square root of 2, which will give us 3 times the square root of 2 as our simplified version. Now guys, the most common mistake with a problem like the square root of 18, you guys might say, well, I know the factors of 18 are 1 times 18, 2 times 9, but I want to use 3 times 6 because 6, you know, that's an even number. It must be a perfect square. Think to yourself though, is anything multiplied by itself 6? No, 3 times 2 is 6, but 3 times 3 is 9. It does not equal 6. So make sure we're continuing on with that logic that we're looking for a number multiplied by itself as a perfect square. Alright guys, join me for the next video when we start talking about adding, subtracting, and multiplying our perfect squares. And our